Hello, and welcome to my channel. Today, we're diving into the basics of the engine coolant pump, a crucial component in keeping your engine running smoothly and efficiently. They are essential tools used to move fluids by converting rotational kinetic energy into hydrodynamic energy. In this video, we'll cover what centrifugal coolant pump is, its key functions, and some of the applications, design details of the individual parts of the coolant pump. Let's talk about a couple of applications. Centrifugal pumps are widely used in automotive applications. They are used as a coolant pump to circulate the coolant through the engine and vehicle-level cooling system. They also have a wide range of applications on the oceans. In addition to being used as a coolant pump to circulate coolant to drive propellant and auxiliary systems, they are used to feed the seawater to the water cannons to fight against pirates. So, how exactly centrifugal pump works? At the heart of the process is the impeller, which has series of curved vanes. Fluid enters the impeller at its eye location. When impeller rotates at higher speed, it accelerates the fluid velocity into the volute section of the casing. Volute chamber in the casing then facilitates the discharge of the fluid out of the pump. Now, let's talk about the key functions of the coolant pump. Firstly, the water pump generates the coolant flow to remove the heat from critical engine components such as engine block and cylinder head. In the closed-circuit system, such as vehicle cooling system, all the components and the plumbing add to the system restriction. It is a job of water pump to overcome these restrictions and maintain desired system pressure. Of course, coolant pump is not free. It draws power from either engine or battery. Minimizing the parasitic losses is critical as we drive towards fuel-efficient transportation. And lastly, coolant pump need to work across all operating conditions. Common coolant pump performance depends on engine speed. Higher the engine speed, faster the pump spins, and higher the flow it generates. However, in some applications, pump need to perform independently that of engine speed. This is normally achieved by electric or variable speed pump. If we look at different types of water pumps used in internal combustion engines, they are mainly based on how they are driven. Belt-driven pumps are most common due to its simplicity and low cost. This type is widely used in automotive vehicles. However, slippage can be a concern with belt pulley system. Gear-driven pumps are used in heavy-duty engines where durability is important. Gear mechanism can also provide compact design. Chain-driven pumps are normally used where application demands minimum slippage, such as high-performance engines. Next, we have electric pumps, which are used in hybrid and EV vehicles. They are not dependent on engine speed because power is drawn directly from battery and not the engine. And lastly, some companies are using variable speed pumps, which are very similar to mechanically driven pumps, such as belt-driven, except these pumps use the viscous clutch to change the pulley diameter to downspeed the pump at higher engine speed. This pump provides better power parasitic by slowing the pump at higher engine speed. Okay, now let's talk about various parts that goes into the centrifugal coolant pump. First and very important part is the impeller. This is the rotating part that transfers energy to the fluid. As it turns, the impeller causes the fluid to move outward and gain velocity. They are typically made from plastic material in automotive applications. Design of the impeller vanes is very complex and plays the vital role efficiently functioning of the pump. Next, we have a mechanical seal which prevents the leakage of the fluid from impeller side to the bearing side. This is a complex system of two pieces, one being a rotor that is attached to the shaft, and the other is a stator housed in the casing. Very small gap between high-spinning rotor and stator part of seal creates the negative pressure. This is how the sealing is created. However, Very small amount of fluid weeps through this gap, which helps to cool the seal and lubricate the seal faces. This fluid is eventually drained from weep hole in the casing. Then, we have a shaft which connects the impeller to the motor or engine, allowing for the transfer of energy. Centrifugal pumps are equipped with bearing and bearing housings to support the shaft and reduce the friction. Lastly, we have a casting, suction, and discharge ports are housed in the casing along with volute. Let's talk a little more about the impeller design. Blade design is where the main trade-off between pressure and flow rate happens. Designers need to think about factors such as vane shape, number of vanes, and spacing available. Another design choice is between open versus closed shroud impeller. Closed shroud offers higher efficiency, but manufacturing can be tricky if injection molded plastic material is used. Impeller design is mainly driven by the performance requirements from the pump and what pressure versus flow trade-off is expected. Cavitation is another factor to consider while designing the impeller. In terms of material, as mentioned before, plastic is most common material due to cost and corrosion resistance. However, some applications use metal impellers if the durability and heat resistance is important. Mechanical seal is another important part of the water pump. Pump leakage is common across the industry and mainly attributed to the seal failure. This seal has two parts. One is a rotating part, which is mounted on the shaft, and another one is a static part, which is housed in casing. Very small space, in microns, is designed between two faces. When the shaft spins, we have one piece of seal spinning at high speed, while other is stationary in very close proximity. This creates the high negative pressure in this narrow gap, and the sealing is achieved. Very small film of coolant is generated in this gap, which acts as lubricant between two faces. Thanks so much for watching. If you enjoyed this video or found it helpful, give it a thumbs up. It really helps the channel grow. And don't forget to hit that subscribe button and turn on the notification bell so you never miss an update.